Welcome to Factoring Day 2. And today we're going to try to link an exercise we did earlier with x's where we try to have a pair that multiplies to give us this number and sums to give us this bottom number. So we're going to apply that to try to factor this expression. So in this expression we have a as 1, it's understood, b is the minus 4, and c, the constant, is the minus 21. So we'll put the c up here, minus 21, and we'll put the b, which is minus 4, down here. So now to factor this, we have to think about it, and we have to think, what are the pairs that multiplied together give us 21? Well, we have 21 times 1. We have 7 times 3. And so let's look at these two pairs. And we said the two multiplied together have to give us a negative. So that means one of the numbers has to be negative and one has to be positive. And we say that summed together they have to equal minus 4. So the larger of the two numbers has to be negative. So we'll put the larger number over here and the smaller number over here. So now, if I think about that, if I take a minus 7 times a plus 3, that gives me minus 21. Minus 7 plus 3, summed, gives me minus 4. So that works. So this is the pair that we end up using. Okay, so now, if we break that into factors, it's just x minus 7 times x plus 3. These are the two factors that we get for this expression. Now if we wanted to prove that, now we're done at this point, but if we want to verify that, we can use the FOIL method and take the first term, x times x, the outer term, x times 3, the inner terms, minus 7 times x, and then the last terms, minus 7 times 3, minus 21. We combine these two like terms, and we end up with x squared minus 4x minus 21. Now if we look at that and we go back, well, that's what we started with. So that worked. So now let's try a second example along those same lines. So I'll clear off the board, and if you had difficulty with this, you might want to pause the video or go back a few steps. So we'll get rid of this. And we'll try one more. Alright, so the next one we'll do, we'll take x squared plus 7x minus 30. And we'll make an x for that, so we can use that tool. So we take the c, which is minus 30, and b coefficient is 7. So now we have to think about what pairs multiply together to get minus 30, but sum together to get positive 7. So we'll take 30 times 1. We can take 15 times 2. We can take 10 times 3. We can take 6 times 5. So here's different pairs that we could use. So now the question is, we have a negative number, so that means it's going to be a negative and a positive. And the positive is going to be the largest number because the bottom sum is a positive 7. So we'll put the positive over here and the smaller number over there. Just for convention, just to be consistent. It's not necessary. Alright, so if we think about these pairs, what can we multiply, but yet what can we add together and get a positive 7? Well, it looks to me like the 10 and the 3 would be promising. So plus 10 and a minus 3 would give me a plus 7. So my factor, I would have x plus 10 times x minus 3. And we're done. Those are the factors for this expression. By the way, this technique only works if the coefficient of x squared is 1. If it's more than that, there are other techniques that can be expanded on, but it doesn't work exactly like this. Okay, so if I want to verify this, I can use the FOIL method. Use the first terms, x times x is x squared. The outer terms, which would be x and minus 3, minus 3x. The inner terms, which would be 10 and x, 10x. The last terms, which would be 10 and minus 3, minus 30. Now I can combine these two like terms, and I end up with x squared plus 7x minus 30, which lo and behold is the original expression. And there we have it.